Hello everyone. In this video, I'm going to give a bird's eye view of all the courses which are studied as part of an undergraduate computer science program. I discuss broadly about all the courses and how each course is linked to another course and what are the important textbooks and references that a student can follow to get understanding about all the courses in the computer science program. This video is mainly intended to those who would like to pursue computer science as an undergraduate program, and also for those who are already pursuing it so that they get more clarity as to why they are studying each course and how it is going to connect to other courses. Before we dive into each of these courses, first I would like to categorize these courses based upon uh, whether it is software or whether it is a hardware oriented or whether it is theoretical or a practical. Courses which are very much software oriented are can be categorized as computer science program, and courses which are very much related to hardware can be called as computer engineering courses. So any computer science course starts with mathematics courses which are theoretical, and they are also very much connected to the software, so they can be placed in the top left quadrant, and those courses are discrete structures, linear algebra, probability and calculus. The corresponding textbooks and what we study internally will be discussed in later in this video. And we have programming languages like Python, Java, C++, and assembly. But these courses, some of the courses are high level languages and some are low level languages, and some are more comfortable or friendly with the hardware, and some are more high level and it is far from the machine code. Courses like the programming languages like assembly are more closer to the hardware, where we code at an instruction level, whereas programming languages like Python are more high level, and they are more far from the hardware. The C++ are also very much used for hardware level programming, especially in courses like embedded, where C is very much used, and programming languages like Java and Kotlin are very much used in the web and mobile app development. So then we have the core theoretical courses in computer science like algorithms, data structures, theory of computation, relational algebra, databases. All those things comes under the theoretical and software related courses. We have AI related courses like machine learning, deep learning, generative AI, and the traditional knowledge representation and reasoning, AI search algorithms. All those comes under the computer science, and they are more of theoretical and software oriented. And we have practical oriented courses. So here we can see the y-axis. The bottom ones are practical courses and the top ones are theoretical. So in the bottom, top left bottom, we have more of practical oriented computer science courses, like databases. We study SQL, where we write queries and do all the CRUD operations. And we also have a non-relational databases or NoSQL. The famous one is MongoDB. And we have cloud computing technologies, where we try to do all the computation, storage, everything in cloud. And some of the famous cloud hosting services are from AWS, GCP, and Azure. We have big data, which is also a distributed computing and distributed storage, where technologies like Hadoop and Spark, PySpark are very famous. And we have AI, which can be implemented using frameworks like TensorFlow and PyTorch. We have data science libraries like data science frameworks like Power BI and Tableau, and we also have Python libraries for data science and ML like NumPy, Pandas, sklearn, etc. The traditional software development, like the web development, includes both front end and back end. Those are also more of practical oriented, and that can be developed using uh, the front end technologies like HTML, CSS, and JavaScript, and the more recent JavaScript frameworks like React.js and AngularJS. And the backend technologies can be developed using any of the frameworks like PHP, Django, Spring Boot, and Node.js. And mobile app development can be done using Android or the cross-platform development technologies like React Native and Flutter, a Python-based framework like Eve, and iOS apps. So these are more of practical and software-oriented courses which we study as part of computer science. And coming to the hardware oriented courses and theoretical in nature, we study courses like operating systems, computer organization and architecture, digital logic, microprocessor, and also the assembly language programming, usually studied as part of microprocessor course. So in digital logic, we study various digital representation number systems like binary, octal, hexadecimal, and how do uh, we also study about various logic gates like OR and XOR, NOR, complement, all those. And we try to learn techniques to simplify the Boolean expressions. And we have various concepts like combinational and sequential circuits. How do we store data, bits? What is the hardware involved in it? All those things are studied in digital logic. Microprocessor involves much more, and it involves complete technology of what all processor includes. So it is very much hardware oriented, and it is also theoretical, somewhat theoretical, but a lot of practicals are also can be done using assembly language programming. So we have courses like computer networks, embedded systems, IoT, microcontrollers, which are more of hardware oriented and also practical. So computer networks, I have placed it very close to the center because it involves both hardware like working with routers, switches, all those things. But when we study computer networks, we study the 7 layers of OSI layers, and different network protocols and various concepts related to networking. So it is somewhat closer to software and hardware. So it is placed close to the center. And we have embedded systems, IoT, microcontroller, which are very much hardware related, and robotics, which is also very much hardware related. So in this way, we can broadly categorize the courses of computer science as computer science and computer engineering. Computer engineering deals with courses which are more hardware oriented, and computer science are the courses which are software and also linked to domains like AI, data science. So we have one courses like security, which are once again involves security at various levels. It can be a software security, hardware security. So that's why it is placed once again at the closer to center. And we have gaming. Once again, the gaming is usually done using a low level language like C++, and it also relies on what hardware we are developing. And because the latency, all those factors are very much based upon the what type of hardware it is being rendered on. So these are the courses which are present in computer science. And we also have the traditional software engineering. We study various technologies, various methods of software development. And we have courses like DBMS, where we also study the theoretical things. We study practicals like SQL and NoSQL, but all the theoretical concepts are very much important in computer science. And also basic electrical and electronics is not a prerequisite, but it is essential to understand, and that falls into the category of hardware. Now let us discuss the connection between various courses in computer science program. This particular chart lists all the courses where the arrow mark indicates the prerequisite of a particular course, and Before we go deep dive into each of these courses, I'll be discussing this in the form of various modules. For example, we have core courses in computer science, we have AI courses, we have full stack development courses, we have electronic courses. All those things firstly we see as modules, and then we will see each of the course and the corresponding reference textbooks and any other YouTube videos which are very much helpful for understanding the concepts in each of these subjects. So let us start with this module. So the first module is about the programming courses. Here we have C language and the object-oriented programming courses like C++, Java and Python. And data structures and DA, although they are not a programming languages, but they are algorithmic concepts which we study and we usually implement using one of these languages. And we also use Kotlin for various purposes, especially for the Android programming. Kotlin is very much used. And we have mathematics courses. As we saw earlier, we have discrete structures, linear algebra, probability, calculus, mathematical programming, and statistical analysis. We have full stack development courses, especially full stack development using Python, using Django and Flask framework, or MERN or mean full stack development, which are JavaScript frameworks, and Java full stack development using Servlet, Spring, and Spring Boot. And we can also see here HTML, CSS, and JavaScript forms the front end part of it, and DBMS is also very much relevant in full stack development. So we have mobile application development courses, especially using Java. We can develop Android applications, although Kotlin is the more standard preferred language for Android application development. And we have cross-platform mobile application development using React Native. Similarly, we have Flutter, which can also be used for cross-platform mobile application development, which means that if you develop a mobile application for Android, you can also use it for iOS or other devices. So we also have a mobile application development using Python. We have a library called Kiv. Using that, we can develop mobile applications. So then comes the core computer science courses. We have seen earlier courses like operating system, computer networks, DBMS, software engineering, compiler design. All this forms the core courses in the computer science. And then comes the electronic courses. The courses like COA, DLP, digital logic and processor, and processors and controllers, basic electrical and electronics, IoT, embedded systems, and including the speech, signal processing, and image processing, basically comes from the electronics part, and which are very much also relevant to the computer science courses. And we have artificial intelligence and data science courses. Usually these are studied as a specialization in computer science, or sometimes AI is floated as a separate undergraduate program. In those courses, in those programs, these courses are very much studied. Python plays a very important role for most of the courses. There are a number of libraries in Python which helps in AI implementation. And so these are the various modules which we have in all those courses which I've shown earlier. Now let us go in detailed course by course and see what are the right textbooks to refer to understand the concepts. Some of the textbooks which are presented here are the classic textbooks which are appreciated by many, and those courses for which there are many textbooks those are not classic or not mentioned here. However, there might be interesting books on it. I'll try to put those book names, all those in the description. Let's start with the first course, which is C language. There is a book by the creator of C, Dennis Ritchie, and this is a classic book to learn C language. Especially the pointer section is very neatly explained in this book. And C language forms the prerequisite for many courses in computer science, many core courses and other programming languages. And although it's age old, but still it is very much relevant, especially for the low level programming. Then we have digital logic and processors. uh, also sometimes called digital design, digital system design, where we study various number systems like binary, octal, hexadecimal, and we also study combinational and sequential circuits. In combinational circuit, we try to minimize the Boolean expressions using something called as K-maps, and in sequential circuits, we study the hardware of how binary bits are stored in memory. So we study both these combinational and sequential circuits in digital logic processor, and this forms the prerequisite for various other electronic courses. So then we have a mathematical course usually studied in the very first semester called as discrete structures, which discuss about set theory, logic, and proportional calculus, and relations, and functions like one onto bijective functions, and concepts of graph theory, vertices, edges, what are paths, cycles, and trees. And these concepts forms very basic for other courses later. And we also study algebraic structure, number theory, Boolean algebra, and mathematical induction in discrete structures course. And one of the standard textbook for discrete mathematics is Kenneth H. Rosen, as shown here. And we have other mathematics courses like linear algebra, probability, and calculus. For linear algebra, we have very standard book by an MIT professor, Gilbert Strang, and this book is considered as a classic, where anyone who wants to get first introduced to the linear algebra can go through this textbook. And it discusses about all the solutions to the system of linear equations, and all the underdetermined, overdetermined system of equations and their properties, and concepts like pseudo inverse, left pseudo inverse, right pseudo inverse, and various decompositions like eigenvalue decomposition, singular value decomposition, and various other concepts are very neatly discussed in this particular course. And we also have probability by Sheldon Ross, which is also an important prerequisite for many of the courses, especially for the courses which are, especially for the AI courses like machine learning. Most of the mathematical concepts which are studied in linear algebra and probability are directly being used in courses like machine learning. So in probability, we study the basic high school mathematics like Bayes theorem, conditional probability, independence, all those things. Along with that, we also study random variables, single and multidimensional random variables, continuous and discrete random variables and its properties, and various theorems, and we also study statistics like mean, variance, standard deviation, and various moment generating function. And we also study correlation, covariance, all those things. So these concepts are very essentials, and especially for the field of AI and data science, statistical analysis becomes very important, where we studied z-test, ANOVA test, t-test. All those tests firmly rely on the concepts of probability and theorems like central limit theorem, so which we study in this particular course. Then we have calculus. There are many books for calculus, Thomas calculus and Creswick, all those books, so I'm not disclosing here. I'll try to put that in description. And we have HTML, CSS, and JavaScript, which are the front-end technologies which are used to develop the user interfaces, web user interfaces. JavaScript is considered as a computational cousin to HTML and CSS, so it also allows us to compute. And we have frame references like W3 Schools gives a very good overview and complete knowledge in HTML. And for JavaScript, there are many books, but javascript.info try to summarize or has an elaborate discussion on JavaScript. Books like Head First JavaScript are also can be considered referring to this. And we have 3 object-oriented programming languages: C++, Java, and Python. Although there are many others which I am not disclosing here, but most prominent ones are the ones which I am showcasing here. Python, all these object-oriented programming languages first discuss the object-oriented programming concepts like encapsulation, polymorphism, inheritance, and their implementation and the syntax. Both C++ and Java has a similarity in terms of syntax with respect to C language, whereas Python has a completely different syntax. Python is much easier but slightly slower as compared to other languages. C is, since it's a low level, it's extremely fast and especially used in the low level implementations. Python provides extremely good number of libraries, especially related to AI and data science, and it is very much used in those fields. And for Java, Herbert Shield is one of the excellent classic book which we can refer to understand all the object-oriented programming concepts in Java. And for C++, the creator of C++ has written this book, and this is one of the good reference for learning C++. And then we have data structures. As you can see here, the concepts which are listed here. Data structures attempts to give the time complexity. First, we learn the notations of time complexity, usually using big O notation, and we try to analyze the time complexity of every algorithm, like starting from the search, linear search, and binary search. And we also study various sorting algorithms. Some are simple sorting algorithms which usually have an time complexity of order of n square, and the efficient sorting algorithms like merge sort and quick sort and various other sorts which has a time complexity of order of n log n. Whereas we also study other data structures like linked list, single, double, and circular linked list, and the time complexity it has for insertion, deletion, and creation, all those CRUD operations. We try to analyze the time complexity. And we have stacks and queues. In queues, we have circular queues and priority queues, and we try to study the use cases of it. And we have trees, which provides a better time complexity than a linked list, and especially for the trees, balanced binary search trees, the time complexity almost reaches to log n base 2. And we study in more detail of how we obtain these balances binary search trees. We study AVL trees, red-black trees, and other trees. And we have data structure called hashing, which is almost gives a constant time complexity with the cost of collisions. And we have a completely non-linear data structure called as graphs, where it allows us to traverse from one node to any other node, and various it's most non-linear data structure as compared to any other. Trees are considered as a hierarchical data structures. And so this is the overview of what we study in data structure course. And some of the standard references for the data structures are from Mark Allen Weiss. He has written books in C++, and Java. And so we have then DBMS, which is database management systems, where we study all the database related concepts. In DBMS, we study various data models like relational, hierarchical, and network models, with a more focus on relational model. And we have database design using entity relationship diagrams. We study SQL, which is structured query language. We also study various ACID properties like atomicity, consistency, isolation, and durability. And we also study various concepts like query optimization, database security, distributed databases, and also non-relational databases like NoSQL. So the standard textbook is Abraham Silvershed's, and this is one of the classic book in database management systems. Then we have DA, which is design and analysis of algorithms. It is kind of an extension to what we study in data structures, where we analyze the time complexity of various algorithms. Here we first get introduced to the asymptotic notations like big O, theta, and omega, and we study various algorithmic techniques like divide and conquer approach, where we apply, which is usually applied in binary search, merge sort, and quick sort. And we also study greedy methods with examples like fractional knapsack and minimum spanning trees. and one of the efficient algorithms called dynamic program is also studied in this course. So the more of the broad objective is usually how we can reduce the time complexity, especially from exponential time complexity to a polynomial time complexity. So algorithms like dynamic program attempts to do that for and it is usually applied for various specific problems like 0 1 knapsack problem, longest common subsequence, and shortest path, matrix chain multiplication, etc. And we also have other algorithms like backtracking, which is usually demonstrated using n-Queen's problem, subset sum problem, graph coloring problem, etc. And we also have concepts like branch and bound, which is usually applied to traveling salesman problem and 0 1 knapsack. And apart from these, we also have graph algorithms like breadth first search, depth first search, and shortest path algorithms like Dijistra's algorithm, Bellman-Ford algorithm. So apart from this, we also have network flow, where we study Ford Fulkerson method and maximum by partition method matching. And towards the end of the dark course, we study the time complexity in terms of we categorize the problems based on the time complexity and notate it using P, NP, NP hard, and NP complete. And so these are the concepts which we study in the algorithmic course, and this is more of a theoretical mathematical analysis of what is the time complexity of each algorithm. And usually we also study space complexity for each of those algorithm. So some of the books are given here: Introduction to Algorithms and Computer Algorithms by Elise Horowitz. And we have AI subject, where we study AI search techniques, and the book is Stuart Russell and Peter Norvig. This is a classic book to learn the AI. It's a very big book containing almost most of the concepts of AI, but AI search algorithms can be very nicely studied from this book. KRR stands for Knowledge Representation and Reasoning. So let us see what we study in this course. So AI search usually starts with the agent and environment, and slowly it discuss about why we need search algorithms to solve the AI problems. As part of that, we study uninformed search techniques like breadth first search, depth first search, uniform cost search, depth limiter search, and other algorithms like iterative deepening search, bidirectional search. And in informed search, we study best first search, greedy best first search, A-star algorithm, iterative deepening A-star algorithm, recursive best first search, etc. And we have local search algorithms and adversarial search algorithms, sometimes called as games, where we study min-max and alpha-beta pruning. And these are the various search algorithms which we study. And knowledge representation and reasoning is about how proportional and predicate logic can be applied for understanding the language, sentences, etc. So this is about AI search and KRR. Then comes to more of a practical course, which is front-end development. There might be many books which discuss about HTML, CSS, but an easy way to learn is for HTML it is through W3 schools, and for more modern frameworks like React and Angular can be learned through YouTube. And one of the best site which I found is NetNinjas, where he discuss about React with practical examples demonstrating each output. And we also have Django for full stack development using Python, and where for front end we can use React or Angular, and for back end we can use Django or Flask. And we also, since we work with databases, DBMS is also an essential prerequisite to have Python full stack development. And the best course for learning is once again a YouTube channel by Dennis Sevi. He discussed thoroughly about Django. And then comes a MERN technologies, which is also a full stack development using completely JavaScript based frameworks. So MERN stands for MongoDB, Express.js, React.js, Node.js, and all the JavaScript frameworks can all be used to develop full stack development. Usually MongoDB, which is a NoSQL database, is used for MERN stack development. Once again, NetNinja has a good course on MongoDB and also Node.js. Then comes JFSD, which is Java full stack development. The front end, you can go ahead with this. We can go ahead with the HTML, CSS, JavaScript, and its frameworks like React and Angular. For back end, the age-old servlets and the current modern Spring and Spring Boot can be used for developing web applications using Java. Then we have mobile applications. In Python, we have a framework called as Skive to develop mobile applications, and the very famous Android applications can also be developed using Java, but the more suggested one is Kotlin, which is a slightly modified syntax as compared to Java. And then we have React Native, which is a cross-platform mobile application development, which means that if an application developed for Android can also works with iOS and other devices. Similar to React Native, we also have Flutter, which can also be used for cross-platform mobile application development. Then now comes to the AI module, where we study machine learning as the course. Machine learning relies on the mathematical concepts of linear algebra and probability, and they are very important to study the concepts in ML. In ML, we study various algorithms like unsupervised, supervised, and reinforcement learning. As part of unsupervised, we learn algorithms like k-means, and we study PCA and supervised algorithms like KNN, SVM, naive Bayes, all those algorithms we study, and based upon the use case, we try to apply one of those algorithms. And the best book is by Christopher Bishop, Pattern Recognition and Machine Learning. And we have Deep Learning course, which relies on the concepts learned in machine learning. In the machine learning, one of the algorithms are neural networks, and these neural networks are developed more further and more detail studied in more detail in deep learning. So in deep learning, we study first a fully connected neural network, and then we go to convolutional neural network, where we try to learn kernels and reduce some of the limitations of the fully connected neural network. And we also study the sequences. We also study neural networks which attempts to understand the sequences, especially for the languages and the time space series prediction. And the best book is Anne Goodfellow, Deep Learning book. And the Gen AI is a more modern, more recent invention, where technologies like ChatGPT and various other AI tools are utilizing the Gen AI concepts. Some of the well-known concepts like transformers and stable diffusion, all those comes under this category. And these AI concepts are applied to one of those fields like NLP or a computer vision, or fields like speech processing. And NLP relies on the concepts of text processing, so where we study tokenization and sentence segmentation, stemming, lemmatization, stop word removal, and n-grams representation like bigram, trigram representation. We also study vector representation like bag of words model or word embeddings, and we also do semantics and sentiment analysis. We apply the latest deep learning algorithms like BERT for text processing to do various tasks like sentiment analysis, etc. So we have signal processing, which is very essential to understand for speech processing. This forms the prerequisite for speech processing, and these concepts can be learned by a very classic book called Oppenheim, where he discusses about time domain and frequency domain representation, where we study Fourier transform, discrete version and continuous version, and various properties. We also study what is called as convolution, one-dimensional convolution, and linear and circular convolution. All those concepts are studied here. We also study filtering, what is a low pass filter, high pass filter, band pass filter. All those are studied in this signal processing course. And a two-dimensional version of the signal processing is the image processing, where we study two-dimensional Fourier transform, two-dimensional convolution, and also concepts like two-dimensional DCT and various other concepts. These forms the prerequisite for the computer vision course, where we study in much more detail, where we try to understand the scene around us using various vision algorithms, where we start with a simple pinhole camera model, and we apply all the image processing concepts like 2D Fourier transform, 2D filtering, and we also study edge detection using gradient, Laplacian, and canny edge detection, corner detection using Harris corner detector, half transform, active contours, shift and surf algorithms are all studied in this computer vision course. And the best resource is, there are many books, but one of the YouTube channels which is First Principles of Computer Vision elaborates each of those concepts, and the textbooks like Seslinki and Richard Seslinki and various other books are also very famous, which I'll list in the description. Signal processing forms the prerequisite for speech processing, and each of these speech, computer vision, NLP are the domains where ML and deep learning algorithms are applied. So for speech processing, digital processing of speech signals, Koteri, all these books are very good to understand the basic speech processing concepts, where we study how we represent speech signals, and like how do we extract features from speech signals, like Mel frequency capsule quotients, and we study what are called as linear predictive quotients, and we study algorithms for speech coding and compression, and also the speech recognition. So all these are allows a particular student to get ready to become a ML engineer. So ML engineers needs knowledge of Python and mathematical concepts like linear algebra and AI algorithms like MLDL, and with the domain specific knowledge of computer vision, NLP, and speech. So these are the courses which makes them be ready with ML engineer. Sometimes it also requires web and mobile application development technologies together to develop a full-fledged application. So now comes data science and visualization, where we apply various statistical analysis to techniques like ANOVA and the t-test, z-test to infer the insights from the data, and we also try to see how we can bestly represent and visualize the data. Then we have big data, where we try to study distributed computing and distributed processing and distributed storage. Technologies like Hadoop, Spark attempts to do the distributed processing. We have data warehousing and mining, where we study ETL, where extract, transform, and load. So we also study we study techniques like data integration, data storage, and performance optimization, etc. In data mining, we study data mining techniques like classification, clustering, association rule mining, regression, etc. We have a course called as Graph and Web Analytics, and SMA stands for Social Media Analytics, which relies on the graph algorithms which have been discussed in AI search and also DA, and also the graph definitions, everything we study from discrete structures. So discrete structures, AI and DA forms a prerequisite, and implementation can be done in Python programming language. And all these things, data science and visualization, big data, data warehousing and mining, and various data analytics courses together allows us to become data scientist, data engineer, and data analyst. Mathematics, especially the probability, statistical analysis, are very much essential. And coming to mathematical programming, this is about optimization. We have linear programming, and we have quadratic programming with quadratic constraints, and semi-definite programming, conic programming, and various nonlinear programming are studied in this mathematical programming course. It's a purely mathematics course. Uh, it can also be called as optimization. And we have now comes to the core computer science courses like operating systems. So operating system is like a software which manages the hardware and software resources in a computer, and how it should function, what is the design, architecture, everything is included in the OS. And OS manages how the resources should be allocated, and everything, where we study concepts like process management, what is a process, what is threading, synchronization, scheduling, all those concepts are studied. We also study memory management, file systems, input output management, and other concepts in operating system. Then the book by Abraham is a standard textbook for operating systems. And coming to computer networks, we study all the layers, OSI layers in computer networks, where we start with first with basics of networking, like what is network, protocols, bandwidth, and types of networks like LAN, WAN, MAN, and PAN, and network models like OSI model and TCP/IP model. And then we go into various layers like data link layer, network layer, transport layer, application layer. The 7 layers of OSI will be studied thoroughly in networks. So security is also very much linked to network, and computer networks becomes the prerequisite for security. Various security algorithms using hashing are studied in this course. And then we have, for computer networks, we have ROS. Keith Ross is one of the standard book. Then we have cloud. For cloud, both networks and OS becomes the prerequisite, where we study private, public, and hybrid clouds. And nowadays, most of the in-house computing is being moved to the cloud, and so hosting services like AWS, Azure, and GCP are becoming famous for cloud storage, cloud computing, and all those cloud concepts are studied in the cloud course. Then comes BE, which is a electrical and basic electrical and electronics, which is not a completely prerequisite, but it is essential, especially when you are dealing with core electronic subjects, like something like processor and controllers, or when we are applying to robotics or other domains, BE plays an important role. We have IoT, which relies on the concepts of cloud, computer networks, and controllers. All the subjects forms the prerequisite for Internet of Things course. We have embedded systems, where COA, computer organization and architecture, is very essential. So in COA, we study how hardware is being actually implemented. How do we do the additions, and how hardware functions is all going to be studied in the computer organization and architecture. So then we have embedded systems, which is also one of the electronic course, and usually implemented using embedded C. So C language becomes a prerequisite, and sometimes C++. And both COA and C language are kind of a important requirements to study what is called as compiler design. So compiler design deals with how a high level language code can be converted into an executable code, what all things we need to consider to make it executable, where we study lexical analysis, syntactic analysis, and semantic analysis, and finally how to have an intermediate code generation, and finally convert into the machine code. All this process is studied in the compiler design. And so this sums up all the courses, but usually not all these courses are placed in a limited credit B.Tech or bachelor's program. So usually some of the courses are omitted. And I forgot, like there is also software engineering course where all the various design patterns and different methodologies like waterfall model, agile technologies are all studied in this software engineering course. And we have uh, gaming and animation is one field where game development can be done. C++ is mandatory for game development, and these are other libraries which we use when we implement or when we do it in practicals. Especially TensorFlow, PyTorch are used for deep learning purposes, and Power BI, Tableau are used for data science and visualization. Scalar, NumPy, Pandas are used for machine learning. MATLAB, and there are certain domains which are not emphasized. This particular In this video we more emphasized on AI and data science, but fields like cybersecurity, blockchain and other domains are also there. Those are not emphasized here. And cross-platform mobile application development can also be done by Flutter, which is actually very famous, where codes can be written in Dart. And we have .NET framework, C# programming language, PHP, virtual and augmented reality, many other domains. And other technologies like GitHub are very much used in industry, and for scientific writing we use LaTeX, and for 3D models we use CAD. So this summarizes all the courses which are there as part of computer science. And usually some of the courses are omitted because of the limited credit cap. So but it is essential to understand the connection between each courses so that we appreciate the importance of each course and what is needed before we actually pursue that course. I hope this video might have given a clarity on various type of courses and the interconnection between them. And there might be, I don't know, a few courses which I might have missed. Maybe you can message in the comments. Yeah, thank you so much for listening.